Hi and welcome to the Embedded Coffee Maker project. This will be your final project. I'm giving it to you early so you can start working on it. Give you several weeks to spend on it. And the final project we're basically going to implement with our embedded skills that we've been learning. We're going to implement a coffee maker. So you can see here I took an example coffee maker where you see there's an on-off button, and you can decide whether you want a strong brew or not. There's 4 different buttons for cup sizes, and you see there's also some status LEDs as well. We're going to implement this coffee maker using our STM Discovery board or equivalent. I know a couple students have boards that are similar to this one, might not be the exact one, but as long as you have that or equivalent, that will be our final project. So our goals, we want to use the embedded skills that you've learned to create a embedded coffee controlled maker. And again, you'll use your Discovery kit or equivalent as the base hardware controller. You'll use the STM32Cube IDE to write, debug, and run your code. I know some of you are using the STM32Cube MX and TrueStudio, and you're welcome to use that as well. STM32Cube IDE is just the newest one to use. And then, like you've done in your other assignments, as you create this project, you'll be creating a PDF showing your major steps, including some photos of your final board in operation and how it's set up. So we'll quickly review some of the IOs here. When you look at a coffee maker, there's going to be GPIO inputs, GPIO outputs, analog inputs, and also console output. We're going to use our console output to kind of simulate really what would be on, say, an LCD panel. So very quickly for the inputs, there's an on-off button. For those of you that are using the Discovery kit, we know it has a blue button on it. Let's go ahead and just say that's going to be our on-off button. So when you push it, it'll send out a message saying you're on or off, be a toggle button for us. Notice there's a strong brew button on this one, so you can decide whether you want a strong brew or not of your coffee. And using this one as an example, it has 4 different cup sizes. So you'll need at least those buttons to be able to handle as GPIO inputs. Now a question comes up, do you want to do them as polled inputs? Do you want to do them as interrupt inputs? And that's part of your design decision and your design discussion. I'll put on the discussion board where people can discuss which would be the best way to do this. And actually there's several options here. So for our GPIO outputs, notice we're going to have a power on-off LED. So this would use if you're using the Discovery board, use the LED 2. And the idea is just by toggling that, pressing that blue button, it would turn LED 2 on, and press the blue button again, it would turn it off. That'll be our kind of base button. Notice there's also an auto off LED, and so you think about your embedded code, you want to keep a time of how long the coffee maker's been on and auto turn it off if that time has gone by. There's an add water LED, so if you sense your water is too low, you need to turn on that one. There's a strong brew LED if you've toggled that. And finally, there's brew button LEDs, so you can have 4 different sizes. Also, for the analog inputs, there'll be a water level. And so the water level, when you think about it, 0 to 100% for how much water you've got. For this one, let's arbitrarily say we're going to use A0 on our Arduino connector that's on the Discovery board. Also, there's water temperature, and for us, if you've got the IoT Discovery board, you can simulate this using the temperature sensor on that Discovery board. Or if you want to just add another, say, analog input and use an analog temperature sensor, that would work as well. So you have the freedom to make this design as you would like, giving you a lot of leeway here. Okay, the console output, we're going to use this similar to an LCD on a coffee maker, so we'll display the power on-off coming on that. I'll also say this, for those of you that would like to connect up an external LCD display, that's certainly you're welcome to do that. Most LCD displays have a serial interface, and we have an additional serial interface on our Arduino connector. So you could actually drive your LCD connector through that if you wanted to. So here, using at least your console output that we've used in the course, you could say, for example, power on off. When someone presses the power button, toggle it on and off. You could display status messages like what's the current water level, what's the current temperature, whether brewing is started and ended, and so forth. And there's 3 levels of completion on this. You'll have the rest of the semester to work on it. It'll be due at the end as your final project. Level 1, just the minimum requirements, which is certainly okay. I realize we all are busy and have full-time jobs and so forth. So here you'd use your IoT Discovery Board or the equivalent, and you'd use your console to provide your output. The inputs would be from whatever you can get working there on the board itself. So bare minimum, you wouldn't need to have any extra hardware. It's just what's on the Discovery Board. So if you're using only the console, it might be you have to do a scanf on the input to say start brew, or brew on or brew off or something like that. Just use your console input. So that'll be a minimum requirement, and that's fine. If that's what you've got time to do, that's fine. Level 2, though, you want to go the extra step and say, I'm going to add an external breadboard, and on that external breadboard I'm going to have switches, I'm going to have LEDs, and I'm going to connect those up through my Arduino connector that's on the Discovery Board. And so you could connect up those and have more real-life type coffee switch and LEDs. And then level 3, kind of the grand finale, add a water level sensor. And this could be a real water level sensor, sends a analog input based on the water level, or if you prefer, just use a variable resistor, put a voltage and have it where you can vary the voltage over that, and by turning your knob, you could go from 0 to 100% and make that your water level. So the idea is you could modify the A to D that's coming in. And also there's probably a relay in here. I realize I've forgotten to let the water flow into the cup. I kind of forgot that as I put these slides together. The point is, level 3, you'll join what I'm calling the Innovative Coffee Maker Club, and this is when you've just gone all out and you've put a lot of extra work into this. So that's purely optional. It's just for those who want to really get into this. But I want to stress, level 1 is fine. You can certainly do everything from there. I'm hoping to have at least a few people do level 2, add your external breadboard, and if we're lucky, we'll have a few people want to do level 3, where you go all out. All right, I hope you enjoy this. Again, I'm assigning it early. You've got several weeks to work on it. Don't try to do it all at once. Just do a little bit every week, and then at the end of the semester, you can submit it, and you'll have your coffee maker as your final project. All right, I'm Norman McIntyre. Thanks as always for watching.